Hello everyone. Today in this video we will learn how to develop your first RAG-based AI application. We will build a small PDF finder application which will take user input and will find a PDF which has matching title or contact as per user input. We generally have lots of personal PDF documents stored somewhere on our computers. Those docs could be your financial statements, medical reports, travel plan, IDs, salary slips, work contracts, project proposals, personal project plans, etc. etc. And if you have several of such documents, finding the correct documents become frustrating. Additionally, if you don't generally name them according to their content while saving them, then it is really becoming a challenge. In that case, you might have docs like doc1.pdf, doc2.pdf, unknown pdf.pdf, unknown1.pdf. So documents like that. And finding a correct documentation will result into opening each one of them. We will be targeting this use case to develop our RAG-based AI application. You need not to host any LLM locally. Instead, we will use Groq Cloud for free to speak to LLMs for our application development. So let's get started. But before jumping into the code, let us understand the three major components every RAG-based AI application will have. Those are, number one, embeddings. Now, how does a computer understand the meaning of the text to find relevant documents according to user input? It's done through embeddings. So the module embedder.py in our project basically provides a definition on how to create vectors, which is actually a numeric representation of the text. Embedding is done using pre-trained model specified in our config like bgesmall and version 1.5 to convert chunk of text into list of numbers or vectors. Think of these vectors as numerical representation of the text meaning. Text with similar meaning will have similar vectors or numbers assigned to them. Number two component of RAG-based AI application is indexing. In our project, the module is indexer.py. Now, as we have embeddings, means we know how to convert the text into vectors or numbers. Now we need to trigger embedding method we defined, efficiently store the vector and provide a way to search through them. That's where the indexer comes into the picture. Indexer uses a vector store library. In our case, it is FAISS. The indexer takes documents and their embeddings and build a spatial database, an index, optimized for finding vectors similar to a query, which user gives. The third component of RAG-based AI application is the actual AI part, which is LLM handling. In our project, the related module is LLM-handler.py. The LLM part of the application is actually the connection to the brain, the large language model. Based on the config.py settings, it initializes the correct LLM client like Groq or Ollama. It provides a simple function like generate response to send the prompt to the LLM and get the generated text back. You will find more modules in the project apart from above three. Those are mainly used to integrate the above three components together and make the app working. Now, as we have a general idea about the three major components of an AI application which uses RAG, now let us have a deeper look into the code of these three components. Please note, for this application, we are using Groq Cloud or Ollama optionally. Setting up Ollama or Groq is not the part of this video. Groq Cloud account creation is fairly simple and you can get the API key from Groq Cloud in a few minutes. And setting up Ollama, I have already explained in separate video. Please have a look. Now let us have a look into the code of our all three major components of RAG-based AI application: embedder, indexer, and LLM handler. Let us open the module called embedder.py. This is a very simple module and contains a class with a single property called model. This is the model which will be used for creating vectors. If you have a look into config.py, we are using this bgesmall en version 1.5 as an embedding model. Now let us open indexer.py module, which actually using the embedder to create embeddings or vectors. If you have a look into the constructor of indexer class, it takes embedder and index directory as input. Index directory is a directory where the index files will be created. This is directly into our project structure. Apart from that, this file has several methods. The method where we can start is setupIndex, which is being called directly from the main method. This function basically checks if the indexes already exist, as in our case. If we start our application in this stage, this check will result into true. And the indexer module only loads the indexes which are already created. But if there is no indexes created, it will rebuild the indexes from the scratch. Here, the rebuild index function comes into the picture. It will remove first of all the indexes if exist. Then it will load all the PDFs from PDFs directory. This load PDF function will simply return document objects for each PDF in the directory called PDFs. Then out of these document objects, indexes are created by this function, create and save index. If we have a look into this function, it takes list of document objects. And the key work is being done here, where the vector store is being created with the document supplied. And the model. Yes, this is the same model that has been defined in the embedder. Now, once the vector store has been created, now it's time to save the indexes. The save index does the job. The save index method, after applying some checks, saves the vector into the vector store locally. Another important method in this module is search, which basically takes a query, which is the input provided by user, and tries to find the similar document according to the query or the user input. The factor k here is defined equal to 2. It means at max, the vector store will return you 2 documents. You can adjust this number as well. So these are the main methods in our indexer.py. And the third component is LLM handler. Let us open it up. The most important method in this module is getResponse, which basically takes in the user input along with the system prompt and returns a response after consulting LLM, whether it's running in the Groq cloud or you have hosted locally using Ollama. That decision, whether you are using Groq cloud or you are using locally hosted LLMs in Ollama, is done by this method. So this is a quick overview of our all three main components of RAG-based AI application. You can browse the code in depth. Code is available in GitHub repository. Apart from these three main components, indexer, embedder, and LLM handler, we have a few more modules in our project. Let us have a quick look into each module. The config.py module basically have the settings for your AI application. So like LLM provider, which LLM provider you want to use. Either you are going to use Groq cloud for your application or you want to host LLMs locally. That, by the way, would be a recommended way if you are going to use this application with your real PDFs. So if you want to use Ollama, then the model in this setting will be used. If you have used Groq, as you see in this setting, so this model will be used. So there are a few more settings like PDF directory, Groq API key, index directory, embedding model. Embedding model is used to create the embeddings, to create the vector store. Then there is data loader.py module. It basically loads all the PDFs from your PDFs directory and returns you a list of document objects, and this document object is created one per PDF document. So this function does the exact thing what I said. It uses this PyPDF loader library to load all the PDF files and their content, and finally it is creating here the document object with the text created from the page content and assigns one more property that will be the file name. So at the end, this list of document object is being returned. Then embedder, indexer, LLM handler we have already discussed. Then there is main.py. We will have a look into the main.py in a moment. Let us have a look into the query engine.py first. So this is a query engine. So query engine, as you can see in its constructor, it takes the indexer and LLM handler. So it has all the tools. This module basically has all the tools required to retrieve the correct PDF according to the user query. So this get relevant docs, it consults a RAG system first of all to provide the most relevant documents out of all those without even consulting to LLM at the end. Once you have those outputs provided by the RAG system, then we provide this as an input to the LLM system to further provide the more accurate result, more accurate PDF which user is expecting. So here you can see the above function is called here. We have a relevant PDF suggested by the RAG system. Then we are retrieving, these are the document objects. So we are retrieving the file names only from here. So, and we are converting them to the unique file names by converting the list into the set, so that we have only the unique file names, no duplicacy. And then we are creating a prompt. Here is the final call being made to LLM for the final suggestion. So one thing to note here is we are just passing the file names and user query to LLM. We are not passing the full page content, full document content. This way we are saving some tokens to be exchanged with LLM system. This way LLM will have to process less amount of data. The result will be faster, but will not be more accurate when we would be passing the full page content. So you can here experiment by passing the full page content as well. So these are the document objects. It is giving you the file names. There should be some property which you can which will be having the actual document content as well. So that you can also pass in as an additional thing. User query, here you can put like PDF names, then PDF content. Because there are multiple names going in, so you can create a map here, a dictionary like data structure, like this file name, unique file name 1, unique file content 1, and unique file name 2, unique file content 2, things like that. You can map it here. In that case, the token exchanges, the cost, the time will be longer because LLM has to process a lots of data, but the results will be more accurate. So finally, this prompt is sent to the LLM handler to generate a response according to user query, and it suggests you, okay, which PDF is most suited according to the user query. And at the end, we will have a look into the main file. Basically brings everything together and make the app working. Create directory, so it tell you it takes an argument directory and it will create a directory. It's basically a utility function. Initialize components. This is an important function. It does initialization of all the other modules. The data loader has been initialized, the embedder has been initialized, and it has been passed to indexer's constructor. So indexer already knows about the embedder. So that's important to understand. So indexer afterwards is passed to query engine, and query engine also has LLM handler. So query engine has all the tools as we have seen. So indexer is having embedder. So indexer know how to create index, the vector store, the vectors using this embedder. And query engine have indexes and LLM handler finally. Then we have a query loop. It's basically an infinite loop which takes the user input, passes it to the query engine for RAG consultation, and then LLM suggestion happens and result is given back on the CLI, and then it's ready for the next input from the user. So this is an infinite loop occurring here. Then at the end we have our main function which calls every other function to make the application actually work. So initialize component function is called, and it returns you a tuple of data loader, indexer, and query engine. Then we are checking here if the indexes already exist. So there might be cases that after the first index creation, after you have ran the application first time, you added more PDFs here afterwards. Please note that in that case, if you want your newly added PDFs should be taken into account, the indexes should be made for them as well. You will have to rebuild the indexes. So that's exactly what it is doing. So it is giving user a choice if a user want to rebuild the indexes in case indexes already exist. So that's just that choice this check is providing. So if yes, then a rebuild will trigger. If indexes does not exist at all, then it's even a simpler case. Then you set up everything from the very beginning, and at the end it triggers the query loop, which in fact is a infinite loop that we saw already here. So these are all other modules available. For our application to work, we need some PDF documents so that our AI application go through all those PDFs and find the relevant PDF documents as per user query. So in order to get the PDFs, one way would be you use your real PDF. That's the actual purpose of the AI application. But for the demonstration, I have several PDFs in my PDF folder of the project. Those PDF contains dummy data and are generated using the LLM itself. How they are generated is using this PDF gen.py module. So this PDF makes use of certain prompts and consults LLM to create a PDF content, and this module then writes that content into a PDF file, into an actual PDF file, and it also consults LLM to decide the title of the PDF file. So I won't go line by line of this module, but it's important to note some major things in this module which you can also tweak if you want to change the content, the theme, the type of the document. So first of all, there are some constant values, PDF directory, which of course in my case is application, inside application, a PDF folder, and how many PDF you want to create, and every PDF how many words it is going to have. So this count decides how many words will be in your PDF document. So retry and the timeout thing we are having here when we consult to LLM and we request him to generate certain document. So what should be the retry and timeout setting? This is deciding, these variables are deciding those things. Apart from these constants, there are a few more things which you can tweak and you should know. There are these two important prompts. Get prompt for story generation. This function return one of the prompt that is related to story generation. There are 4 major factors which we choose randomly. For example, theme of the story, location of the story, country of the story, and the timeline of the story, on which we want our story to base upon. And after generating the random values of all those 4 factors, we combine them together in a text which we call a prompt, and this prompt is sent to LLM to generate a story content. Similarly, we have a prompt generated for documents, the personal documents. So there can be a list of the documents here, and you can add or remove as per you want. And using one of the randomly selected type of the document out of that list, we create a prompt. I have explicitly mentioned that don't use real world names, instead use XYZ or ABC like things while creating personal documents like ID or things like that. Similarly, I have instructed in the prompt to LLM that don't use the real street names or house numbers, so that they don't even accidentally matches the real world people or addresses. Yeah, and once the content of the document is generated, then we also consult LLM based on the content to generate the title of the PDF as well. So that is done by this function, not done by this function, but this function actually returns you the prompt for title generation of that document based on the PDF content. So first step is to generate the PDF content, then you again send a part of the PDF, not the full PDF, but only the part of the PDF to the LLM to give you a relevant title for the PDF with which the PDF will be saved on your disk. So these are the a few main things in the PDF generation.pdfgen.py module. So to run this, you can simply press the run button in the VS Code itself, or you can run the pdf_gen.py using CLI as well. And you can of course tweak these values and the prompt as I shown you, and based on that the PDFs will be generated in your designated folder. And we can base our AI application, which will be finding the document as per the user input, and we can base our application on this folder. To run the document finder AI app, you can simply run the main method or the main Python module from here. But before doing that, don't forget to install all the required dependencies which are in requirements.txt out here. And another important thing before running your application is tweaking those variables, especially the LLM provider, the Groq. If you have chosen the Groq cloud to run your application upon, then the Groq API key should be set in your environment, and that's a major thing which you need to take care. And of course the PDFs you have already generated using pdf_gen.py module. As I have installed all the requirements from here, so I can directly launch my application using the main method. So I will just press the run button from the VS Code and my application is started. So the first thing which you see in the prompt is rebuild index with current PDFs. I will choose no because I have not added any extra PDF since my last run. If you choose to run, it will create the new indexes or vector store with the PDFs you have in your PDF directory. So I will choose yes. It will take some time to create the new indexes, but it's really fast here. Now you are ready to speak to your AI application as you do it with any other AI application. So I can start giving the queries or try to find a PDF document in my natural language. For example, I want to find a salary slip. So I will write like salary slip from, for example, March of year 2023, for example, and if I press enter, then the engine starts working, and it is saying like, first you see the output of the RAG system, the semantic search the RAG has triggered. So based on that, RAG suggested these two documents might be relevant to the user query. Then these two documents and their content is sent to LLM to give you more accurate results. So what LLM's final response is, if you see somewhere here, based on the user query, the suggested file to check are these things, these files: salary statement for financial year 2022-2023 details.pdf. So it has given me the exact document. Now you can open it and verify whether this document is having the desired details or not. You can simply go just for the verification sake if it has produced the relevant or correct results or not. So does this file contains anything related to year? Yes. So yeah, it somewhere mentions like 2023, so the AI has returned the correct document, I will suppose. So you can ask variety of queries to this system. For example, any horror story, it will try to find. First goes to RAG suggests something, and these two things are sent to LLM for more accurate results. So it has suggested like Whisper the Island. This PDF, to be specific, might be related to the user query. Now let's try to give some more user queries here and ask our system to produce some outputs. Now let us give the system some more inputs. Document mentioning travel plan. So passport is not really a travel plan, but RAG assumes that okay, this might be related to something traveling. ID card it has returned. But LLM gives you more specific suggestions. Neither of the listed PDF files appears to be directly relevant to the user query about a document mentioning travel plan. So it gives you, there is nothing like a travel plan related things. But still, if you want, you can have a look on those. These can be useful. So marriage certificate. Yes, it found a few. Let us now try to find some medical reports. Show me the medical report related to, for example, knee injury. These all are the dummy details, so it's not real. So it gave me two things: RAG system, salary statements, but it gave me a medical report of a dummy person XYZ123. But what LLM says here is none of the listed PDF seems particularly relevant to the user query about knee injury, but still you see some medical reports here. So there is nothing related to knee injury here. Bank statement from year, for example, 2020. We have some financial statements, financial documents, but none of them, as you can by the title already guess, it's not a bank statement, especially from 2020. So that's a similar response from LLM, the final response. Any CV is there? Yeah, we found some marketing and sales professional resume, tech industry resume. Yeah, so we have it. So system is working quite nicely. Let us try to find some stories. A story related to medieval time in India, that for example. Is there something? So it gave me the rack system written with 2 PDFs here. 15th century Mumbai. So it gave me a relevant, very specific document which is directly related to the user input. That was the medieval time story from India. So yes, it gave me very correct result here. Let us ask a few more questions. Any personal project plans? Yeah, it looks so. Financial statement, it's not directly related, but please note what I asked. I asked for any project plans. So it gave me 2 results. What AI said at the end: neither of the listed PDF file seems directly relevant. So there is nothing like personal project plans. Project proposals, question mark. Yes, I have 2 project proposals here suggested by rack system: eco-friendly manufacturing unit proposal, and another is inquiry about graphic design service. I suggest checking, this is being said by LLM, based on user query, I suggest checking eco-friendly manufacturing unit proposal. That's obvious that you can already think what would be the relevant document. So the system is working quite nicely as a document finder. So yeah, try it out with your personal documents. If you are using your personal actual documents, then I would suggest not to use the Groq cloud, because I mean, for obvious reasons, you are sending your information to the cloud to someone else. So if you don't really want to do that, use Ollama instead and host a small model as per your system or PC configuration. Try to use Ollama locally and speak to your locally hosted LLMs. I hope you find the video informative and useful. All the code discussed in this video is available in GitHub. The link is in the description. Thanks for watching.